Now we will discuss about fractional distillation. This method is also used for separating miscible liquids. Like simple distillation, fractional distillation is also used for separation of miscible liquids. What are miscible liquids? The liquids which mix uniformly with each other. They form homogeneous mixture. And here the difference in boiling points must be less than 25 Kelvin, around 10 to 30 Kelvin. When we take the difference between first liquid component and second liquid component, it must be less than 25 Kelvin. The principle is same. In simple distillation, fractional distillation, it is based on the difference in boiling points of the liquids. But what is the difference? In simple distillation, the liquid components have a difference of boiling points more than 25 Kelvin, whereas in fractional distillation, the difference in boiling points is less than 25 Kelvin. And why the word fractional is used? Because the distillate is collected in fractions at different temperatures. At different temperatures. Now the other difference is in fractional distillation we use a special equipment called fractionating column. Fractionating column. So what is this fractionating column? It is basically a long glass tube. It is a long glass tube. There are different types of fractionating column. Like the glass tube is filled with the broken glass pieces. Sometimes it is filled with the glass beads and it will be molded like it forms a pear shaped fractionating column or circular fractionating column. So there are different ways of making fractionating column, but in a simple way it's a long glass tube. Okay, and what is the main purpose of using this fractionating column here? What is its job? It allows repeated condensations. Repeated condensation. Condensation process generally takes place in Liebig's condenser, where vapors will be turned back into liquid and the liquid will be collected in the form of distillate. But before reaching the Liebig's condenser, the vapors undergo repeated condensation process in fractionating column itself. Why this is done? Because if you see, the two liquids are having very close boiling points. By the time liquid 1 completely vaporizes, the liquid 2 also starts vaporizing. So we have to make a gap, or we have to increase the time gap between the liquid 1 vapors and liquid 2 vapors, and that will be achieved with the help of fractionating column. Let us see examples of fractional distillation. First example is acetone and methyl alcohol. Acetone is CH3COCH3. Acetone is having a boiling point of 330 Kelvin, whereas methyl alcohol is having a boiling point of 338 Kelvin. So when we see the boiling points, there is a difference of only 8 Kelvin. So here simple distillation is not used. It will not work out. We have to use fractional distillation. Now when you see the boiling points, it's very clear that it's easy to reach the boiling points of both the liquids with a very short time. So when we use fractionating column, it will help us to separate the acetone vapors from the methyl alcohol vapors by making the repeated condensation processes. We can take the other example of fractional distillation, benzene and toluene. These two liquids are also separated using fractional distillation. Why is it so? Because these two liquids are having a very close boiling points, so simple distillation will not be used here. Okay, so the figure shows the different types of fractionating columns. Like you can see, it's a long glass tube which is molded in the form of circles, which is molded in the form of pears. This is pear shaped fractionating column, and this is circular shaped fractionating column, and this is the fractionating column that is filled with glass pieces, broken glass pieces. And this is filled with what? This is filled with the glass beads, and this is bubble plate column. So different types of fractionating columns are available. Generally we use the simple packed fractionating column, that is the tube filled with glass beads. And as I told you, what is the purpose of fractionating column? It increases the time gap. Fractionating column allows the repeated condensation process, because of which what happens? Liquid 1 vapors do not get mixed up with liquid 2 vapors. And this is achieved by what? This is achieved with the help of fractionating column. Let us understand the same process with the experimental setup as shown in the blackboard. This is the experimental setup for fractional distillation. So everything is same except the extra equipment, that is fractionating column. So this is the fractionating column with the glass beads. And this is the thermometer which shows the temperature reading. And this is Liebig's condenser. So this is cold water in, and this is for hot water outlet. This is your round bottom flask in which we take the mixture of miscible liquids, and this is Bunsen burner which is used for heating purpose. So here also it includes 2 steps. One is boiling, where the liquid will be converted into vapors, and step 2, condensation process, where vapors will be turned back into liquid, and this liquid will be collected over the receiver flask, and the liquid which is collected here is called what? This is called distillate. Just make a comparison between simple distillation and fractional distillation. In simple distillation there was only one distillate. The other liquid was left behind in the round bottomed flask itself. But in the case of fractional distillation, once the first liquid is collected, immediately we replace the receiver flask. First receiver flask is removed and the other empty receiver flask is kept. Now the second liquid starts collecting in the receiver flask. So like this, what happens? The different liquids are collected in fractions at different temperatures. So we all the time we have to replace the receiver flask for collecting the different distillates. That is one difference. And the other difference, we can see an extra equipment, that is fractionating column. Now let us analyze the same with example. Let me take the example of acetone and methyl alcohol. Here let me take, what is the mixture here? I'm just taking acetone and methyl alcohol. So out of these two, acetone is having lesser boiling point, that is just 330, and methyl alcohol is having 338 Kelvin. So which liquid starts vaporizing first? We can see the formation of vapors of the acetone. So by the time acetone completely vaporizes, the other liquid, methyl alcohol, also starts vaporizing. So there is a possibility that these two vapors get mixed up. So how can we avoid this? With the help of fractionating column. It sends back the vapors of methyl alcohol and it allows the vapors of acetone. Now the vapors of acetone enter into the distillation, into the Liebig's condenser. So where it undergoes condensation process. Now the liquids turn back into what? Liquid. So the first distillate that is collected in this process is acetone. Now once acetone is collected, immediately what we have to do? We have to replace this receiver flask with some empty receiver. Now methyl alcohol starts vaporizing, that enters into fractionating column. then into Liebig's condenser where it undergoes cooling process, and then methyl alcohol will be collected in receiver flask 2. So this is how we separate the different components in the miscible liquid mixture. I hope you are clear with this. If there is any doubt, please let me know. The application of fractional distillation is refining of petroleum. When we take the crude oil which is found in the earth crust, crude oil is also called petroleum, that contains so many useful components like petrol, diesel, kerosene. So all these components, they are separated one from each other with the help of fractional distillation. So there is an application of fractional distillation in real life, that is refining of petroleum. Thank you.